In this example, we want to find all equilibrium solutions to the Thomas equation, given here, and sketch a graph of these solutions for a variety of initial conditions. So the equation we have here is y minus 1 squared, y plus 3, y minus 5 times e to the y. So I want to look for where that function is 0. So if we look at this, we have a bunch of factors here. It's already factored for us. So that means that f of y equals 0 means that either y minus 1 equals 0, y plus 3 equals 0, y minus 5 equals 0, or e to the y equals 0. So here we get y equals 1, here we get y equals negative 3, we get y equals 5, and e to the y equals 0 is never true. So I get no extra equilibrium solutions from this term here. Then I can draw my phase line. I get minus 3, I have 1, and I have 5. And e to the y is always positive, so I can kind of ignore that term when I'm going to look at whether things are positive or negative. It's always going to be a positive number. So I plug in, say, minus 4 for down here. I will see that I get minus 4 minus 1, which is negative 5, squared, so that's positive. Minus 4 plus 3, that's negative. Minus 4 minus 5, that's also negative, so I have plus, minus, minus, plus, which gives me an overall positive sign. If I plug in 0 for this one here, I will see 0 minus 1 is negative 1 squared is positive 1. I see a plus 3 here, a minus 5 here, and a positive 1 here. So plus, plus, minus gets me a negative sign, so that's going down. If I plug in 2 for up here, I will see 2 minus 1 is 1 squared is positive still. This is 2 plus 3, which is positive. 2 minus 5 is negative, so plus, plus, minus, plus is another negative sign, so that's down. If I plug in 6, every single term here is positive, so that gets me up here going away. Which means in terms of classification, so right down at the bottom here, negative 3 is stable, 1 is semi-stable, and 5 is unstable. So for actual solution graphs, we can draw on our axis here at 0. We can draw in our equilibrium solutions at 1, 5, and minus 3, and then fill in between. For the bottom here, we're going to be increasing, or it's going to be concave down for these ones. So it's concave down, going to flatten out to the solution. Right, these graphs will always flatten out to the solution they're approaching. They're never going to come in at a hard angle here. So it's going to be concave down and point out this way. Between 1 and minus 3, we're going to be decreasing. And again, we have somewhere in there, we don't know exactly where, there's going to be an inflection point. So if we start super close here, we're just going to decrease right to the line. If we start further up here, we're likely going to be concave down for a bit first, hit an inflection point, and flip over. And you could go and find the point if you really wanted to, but for the sake of this, we don't really need to. We just need to get an idea of where it is in between these 2 points. Between 1 and 5, we're also decreasing. So we're going to be starting up top here, start concave down, hit an inflection point, become concave up, and if we're here, we just end up being concave up. And above 5, we are increasing, going to be concave up again, it's going to take off that way. That gives us a sketch of what this curve looks like for a variety of initial conditions, where we've picked some between the different equilibrium solutions to sketch out what this is going to look like for the solutions to this equation.